Okay, welcome back to the sixth, and I think probably the last segment of how to build the Reprap Wilson TS 3D printer. As you can see, I've got the completed printer assembly here in front of me, turned around backwards, that we finished in the last video. And then I have the electronics and the power supply. I have the 4-line LCD that I'm using. And then over here to the right I have the remaining plastic parts that will be used to attach the electronics and the filament mount to the top of the printer. So I've already got it turned around. I'll move it maybe a little better so that it's going to be easier to see. We're going to be working close up here on this video. And I'm going to move the power supply and the display aside. And on the ramps board, I'm going to actually take the shield off of your Arduino Mega if they're already attached. And there's two things that I want to point out about the way I'm using the ramps shield. The first is that I'm going to have a cooling fan that blows across these stepper motor drivers, and I actually will have that so that it's turned on all the time. I'm taking advantage of this little connector that's kind of buried right here. Right in there, hopefully you can see there's a 2-pin header that I've soldered onto the board. Yours might not come, it might just be a pair of holes there. But I soldered that on so that I can attach that 12-volt fan and it'll just run all the time. The other thing is that under the stepper motor driver here on the end, pop it off of there, you can see underneath here is a diode labeled D1. There's another one right here that looks just like it that's probably already assembled. Your board might not have this one inside here assembled, and it might have even come with it separately, and you'd have to solder it in. But you want to use that if you are going to be using the printer standalone, meaning that you won't have a PC attached that will provide power to the Arduino through the USB cable. And I am going to be using it that way because I have the LCD controller, so I've installed that diode, and what that diode will do is it'll allow the 12 volts that's connected to the ramps shield to trickle down and power the 5-volt regulator on the Mega. I'll just pop this stepper driver back in place. Make sure those are all down. Okay, so now we can get started. And the piece that holds the electronics onto the side of the frame is just a simple mount. This is the first version that I designed for Wilson. And it attaches right here, and the second piece you put two 30mm M3 screws through this hinge, and then it creates a pivot hinge where you can attach a 12-volt the fan that we were just talking about powering, so that it blows right onto the electronics. Now since then I designed this simpler version that doesn't have a hinge, and the fan will just attach to the side and point straight at the electronics. This version just uses a little less plastic and is a little bit more rugged, so that it won't get broken as easily if you're shipping parts or anything like that. So that's the one that I'm going to actually use today, but either one will work, and they attach exactly the same way. So first thing to do is, again, keep your ramps shield detached. Get the Arduino Mega and line it up on here so that you can see where the holes all 6 holes should line up. However, the 3 holes that are on this side, unless you're using a flush screw of some type, they're gonna hit the frame, so you can't really use them. You could put zip ties through there and it would just, create a little bit of an offset, which would be okay. Furthermore, the 2 screws on the far left, they are too close to these connectors on the Mega to actually allow for a standard screw head, I found. So if you have a smaller screw of some sort, you can probably use them, but I can't. So that leaves me just with this one hole in the middle of the board, and that's what I'm going to use to attach this. I'm just going to use a single M3 14mm screw through there, and then an M3 nut on the back. And then I'll tighten that down. And if you felt like you needed a little bit more to hold it, I guess I would probably opt for a zip tie through these two corners. Just tighten that down, and it'll pretty much, that would actually work just fine. I'll go ahead and attach one, and that way if we have to take the shield off of the Mega, that will kind of prevent it from trying to wrench the Arduino off of the mount. So just tighten that down really good, and that's gonna work just fine. I'll put another one to this lower corner. The reason that I didn't just shift the mounting holes for the Arduino over far enough that those would clear is because then the X-axis motor will actually hit the ramp shield once it's attached on here, because it sticks out to the side. So it was kind of a compromise. But there should be 3 T-slot nuts here left over on this side of the frame. If you used all of the optional ones like I did, the top one will be for the LCD mounting bracket, and the lower 2 are what we want for the ramps. So get 2 10mm M5 screws, just like we used for all the rest of the frame, and put one into each of these lower 2 nuts. You can, about halfway up the frame, just tighten that one just enough to keep it there. And then hold the mount up here. Now you could mount this a little higher, just not too high to interfere with the bracket that we're going to put here. If you mount it much lower, it'll be okay, but with this newer ramps mount, the fan is going to stick out a little bit over this back corner of the bed, and so that if you put this really low, it would interfere with short objects that you might put at the very back corner of the bed. Probably wouldn't ever be a problem, but if you mount this about halfway up, now the parts would not only have to be printed at the back corner, but they'd have to be pretty tall before you'd have any kind of interference. So I think that'll be okay. And now I'm going to get the ramps board, and before I actually attach it onto here, I find that it's easier to attach these first couple items while it's free, so that you can actually see into these little terminal blocks here. Hopefully that's visible. Could zoom in a little bit, maybe. So these first 3 spots, you'll need a smaller screwdriver for this. These first 6 positions actually are for these 3 MOSFET switched power outlets. There's D10, D9, and D8. And the way I'm going to use them is the starting from the left, the heater for the extruder, which is these two wires, will be attached to the first two, and then the fan for the extruder will go in the center tube, and then the heater, the heat bed will actually be attached to D8, which is the one on the right. And this is one of the standard configurations that your firmware will probably support. So you could theoretically put them in any order and then change the firmware, but you'll be better off if you stick to this, I think. So the heater resistor doesn't have polarity, so it doesn't matter which one goes into plus. There's a little plus indicator on the board. So just put them in whatever order you like. If you're using a stranded wire like this, make sure it doesn't fray when you put it in there and short out to its neighbor. And when they're tight, check them. Make sure you can't pull them back out of there. And my fan for the extruder, which this fan isn't on all the time, it's turned on and off by the firmware, is going to go in these next two, and this actually needs to be restripped. And for the fan, you do have to make sure you get the plus terminal to the fan into the plus, and in my case I used yellow for plus. And then the last one will be for the heat bed itself. And my heat bed wire is this old speaker wire that I had laying around. And it's actually too large of a gauge to fit into these terminal blocks. I've noticed that some of the places that put together these ramp shields use a kind of a lighter weight terminal block, unfortunately, and that's what I have here. And so these heavier wires won't fit in there. So I've used these little wire couplers that you can get at the hardware store to convert that down just to a shorter piece of a narrower gauge wire. Now the heat bed itself doesn't have a polarity either. There are LEDs on the board, and the LED has a polarity preference, but there should be two LEDs actually soldered onto your board. Here I have another heat bed that hasn't been used yet, and you can see that there's a spot here for one resistor and then two LEDs. You put the LEDs in anti-parallel so that whichever way you connect power, one of the two will turn on, which is kind of a waste of one of the LEDs, but it makes it so that you don't have to figure out which is plus and which is minus. But if you do only have one on there, then you'll have to figure that out first. Okay. Those three are attached, and we're happy that they're not going anywhere. Then I'll put the shield onto the controller. Just press nice and evenly on the sides. Make sure it's seated well. Next thing that I'll attach are the thermistors. So right here yeah, right here, you'll see 3 spots that are labeled T0, T1, T2. So the first one, T0, is going to attach to the thermistor that's on the extruder at the hot end. And so just trace, figure out which one that is, plug it into the first 2 spots. And it doesn't matter which way you plug that in because the thermistor is just a resistor after all. So, and then the second one is going to be for the thermistor that goes to the bed. So here's that. And try to pay attention as you attach all your wires about where they're going so that they don't get all tangled up, otherwise you'll end up just taking them off, putting them back on. Okay, so there's the 2 thermistors hooked up. And then the next thing that we'll attach are the endstops, and I'm going to try to zoom in a little bit so you can see better. Right here in the upper left corner are the spots where the endstops can attach, and there's an awful lot of connectors here in a small place, and they're not very well labeled. So this is easy to get mixed up on, but they go in the order of X-min, X-max. So there's 2 endstop inputs for each end of each axis. Even though we're only using 1, we're using just the minimums on this setup. So X-min, X-max, Y-min, Y-max, Z-min, Z-max. And this top row isn't related to the endstops. And then furthermore, there's 3 rows of pins here, but it's the 2 on the left that we want. The one on the right is connected to power, in case you had a switch that needed a pull-up or something to work right. So find your each endstop switch. X-min is the one on the x-axis, so it goes in this first set. And you can't get it backwards, as in it could go this way or this way. Y-min is the one that goes down to our Y motor mount. So you skip 1 row and the Y-min goes into the next one. And then the Z is the switch here on the side of our frame. So skip another row and it goes in the next one. So we have X-min, Y-min, Z-min. And then next we just want to get each motor connected. So to the left of each of the stepper motor drivers, you'll see a row of headers. Next to the Z one, there's actually 2, since it has 2 motors. There's 1 unused slot here, that's for that second extruder that ramp supports. So I'll just start hooking these up. Get my Y-axis wire here. Now for mine, these are going to attach like this with the red wire to the bottom, but yours might be different and yours might not even be the same colors. So just take your best shot, I guess, and if you end up noticing that your axis moves in the exact wrong direction after we get the firmware programmed, then you'll know that you got them backwards. Now I'll get my Y motor. My Y motor wire is a little shorter than I wish it was, but it'll do. And now there's 2 Z motors. Take one and bring it up from the bottom here. It's different color because I had to, this motor didn't actually come with a header attached to it, so I had to attach one myself, and I didn't have the right all the different colors of wires, so I had to just do it best I could. And my other Z motor is much longer. It comes from clear across the other side of the printer, and I'm going to tuck the wire underneath, and I'm going to clean this up later with some zip ties, and it just plugs in right next to the first. And then the extruder motor is right here. Okay, so that's all it should be everything. unless I missed any. Oh well, next we need to actually put on the fan. So the last piece of the electronics, standard electronics, is going to be to get our fan on. So I've got a 12-volt fan here. Back out. And again, the emblem on the fan wants to point towards ramps so that we're cooling these guys off. And to mount it, we'll get two M3 by 30 millimeter screws and nuts. So here are those. Okay. And then the power connector for this, like I mentioned earlier, I'm going to pop onto the little 2-pin header that I soldered on earlier. Now as soon as the board's powered, this fan will run. And now I'm just going to kind of tidy up here a little bit with a few zip ties. Okay. Now move a little bit further away here. Now to mount the LCD display, which points towards the front like this, electrically it's going to attach here, and then mechanically there are these two brackets, a short one that goes along the top bar and then a longer one that goes along this side bar, and then together they'll hold that in place for us. So to attach the brackets, the side one's going to use this last T-slot nut, so put another M5 screw through here, and then there's probably different tricks to getting this screw in place, but I'm just going to take a pencil, I'm going to slip a unused screw here just to hold that up. Slide it as far to the left as you can get it, or the left from the front of the printer, and hold that so it's level, and tighten it down, and there should be an adapter board. If your display just comes with these, this might be a separate piece that you need to find. In here at the top, just like that. Next I'm going to attach the filament holder to the top. So these are the last two pieces to be attached to the printer. The two brackets and then a dowel between them will hold the spool of filament on top of the printer. And you should still have two T-slot nuts here in this top groove, and you may have two in the back ones. You can get away with just these top two. They'll hold it, it'll be more than adequate to keep it in place. So get two more M5 screws and make sure they fit in these little slots, and if they don't, then you have to get your drill or get a file and just clean those out a little bit, and then just put each one on here so that the open ends face toward each other. Then before they're tight, get the dowel that you're going to use. So here I've got, this is actually just a little piece of M8 smooth rod that I had left over from something, and it's kind of overkill. I'd recommend you go to the hardware store and just get a piece of 1/4-inch wooden dowel, and this is about 8 inches long. Wiring for the extruder to be in between the two. And this goes just like that. Then you can take this off, slip your spool of filament over it, and you'll be good to go. Now next, last thing to be attached is going to be the power supply. And I've designed these set of brackets that you can use if you want to hold the power supply down to a table. When I'm all set or all finished, I'll probably take the whole printer and I'm going to mount it to a sheet of 1/2-inch plywood just so that I can move it easier, so that the power supply and the printer are all attached rigidly to each other. These brackets just go on each corner like that, and there's a screw hole here in the bottom that will attach it. I'm not going to do that right now, and it's pretty easy. The Rams board should come with these two little connectors for connecting to 12 volts. To connect them to two different pairs of 12 volt and ground wires from the power supply, and then they just attach to each one. Just make sure you have the polarity correct, which is the 12 volts are on the left, viewed from the back side. They snap on there. So our printer now is all ready to go. We just need to attach a computer to program the firmware, and once that's done, it should be ready to print. So I'll get the computer and I'll do that real quick. Alright, so here I've got the computer set up, this little netbook that I'm using for Arduino projects, and I've got the printer with a USB cable from the computer there to the printer, and the power supply for the printer is turned off, so right now I'm just powering the Arduino straight from the laptop, and that'll also turn on your display. When you haven't programmed the Arduino yet, your display will probably just show a bunch of white blocks on the front. And then here I've got the Arduino IDE, and I've loaded the Marlin firmware project, and getting that all set up is probably beyond the scope of what I can show you here quickly. So there are a lot of resources for that already anyway. So let me just show you real quick when you first load the Marlin project into the Arduino IDE, there's a lot of files in the project, and this one here, configuration.h, is the one where you want to set all your specific flags for the printer that you're gonna program. So if I just scroll down here, and we can see anything of interest, here's the spot where you tell it which shield we're using, and this field here lets you set a string that'll display on the LCD if you want. These flags here are to set your which thermistor table you need to use, So you want to get these right, and if your temperature seems way off, you might come back and revisit that and see if maybe you just have the wrong thermistor set. And go a little bit further down here. A lot of these you may never change, but about halfway down here there should be, okay, right here are the settings for the motion. So these are going to be your defaults for setting the number of steps that the firmware has to put out to move each of the motors in the whichever axis exactly 1 millimeter. So there's a calculator, at least one good calculator online to help you figure out what good defaults would be here, and then when you start printing you can adjust them a little bit until they're as close to correct as you need them to be. A little bit below that I have the SD support defined, and then a little below that is the flag for the specific controller that I'm using. So this is the Reprap Discount Smart Controller, and then I don't think there's anything below that that I have changed. So I'm just going to hit, you can hit compile and then upload, or you can hit upload and it'll compile. And nothing's really going to seemingly happen for a little bit. Let's see down here. It's uploading. And now it's done. So at this point the printer should be ready to print. Now what I'll do is disconnect USB, turn on our power supply and rotate the printer around. So the LCD turned on. Okay, it's telling us we don't have a card put in, and this is a real good sign if you see the two temperature readings. So it's telling us the thermistor on the hot end and the thermistor on the heat bed. So that's about room temperature. So it's a good sign that things are basically communicating. I don't know if I can move this out far enough. I'll just try to hold it. So now, first thing I might suggest is you push this knob in to get the menu, and then you scroll down. You're under Prepare, and you can do all these things from your PC if you're not using this display. You should see similar options in Pronterface or a program like that you would use to control the printer directly. But I'm just going to go down here and choose Preheat, PLA, and now we should see the light come on the heat bed. There it is. And the fan here on the extruder also turns on when it's in this mode. And then here we'll see the temperatures start to come up for the two. So that looks real good. And I might go back, go cool down, and then I'll just turn those back off. Didn't actually turn the fan off, but it changed the set points. So that's interesting. And now I'll go back to that same menu. All the way at the bottom is Move Axis. Choose one millimeter at a time, and then I'm just going to try each one of these. X. And you turn the knob. It's kind of jerky because it's just telling it to move a millimeter at a time. But it's moving in the right direction. Moves to the left when the number goes down, moves to the right when the number goes up. I'll try the y-axis. And it's kind of moving, but it's kind of not. So there's a problem there with the y. Before we debug that, I'll go on to z. So when it goes up, it should turn both motors. If only one is turning, then check your wiring. If it's skipping around or making odd sounds, then it might be like the problem with our Y. But this looks like it's working great. Check at this point, by the way, that your Z-axis end stop right here should be pretty close so that it'll... Try to get in here. So the switch needs to hit this end of this screw when we're close to the heat bed. So I'm about an inch above, and I've got about an inch here, so that's pretty close. Just make sure you didn't leave your end stop switch way down here at the bottom where we started, otherwise this will just crash into the bed before it ever gets to the switch. So where were we? We had tested our X, Y, and Z, and the X and the Z worked, but not the Y. I'm going to go back down here and go clear to the bottom for extruder, and then turn the knob a little. Nothing. Numbers change on the display, but the motor's not turning at all. So we got a problem with the extruder also. So turn this around so that I can show you. Okay, so this is our X, Y, Z, and the extruder driver over there. So the one I'm going to try first is to adjust this Y motor. So you'll need a tiny little screwdriver. This is just the end from one. And right above the heatsink for the driver, there's a tiny little trim pot, and I'm just going to turn it to the right clockwise about a quarter of a turn, and then I'm going to go back to the LCD controller here, and I'll go around to this side and go back to move 1 millimeter y-axis. It's acting a little differently, but still not right, so I'm going to turn that up a little bit more. Clockwise is going to set a higher limit. Now it's starting to move, but it doesn't seem real convinced. Just a little more. That looks pretty good. Now the extruder one, it wasn't moving at all, not even a little, and I'm going to give it a turn just to see if that helps. I'm going to turn it about halfway, and then on the display I'll go back to, it times out after a few seconds and you have to go back through all the menus. I'm turning the knob and there's absolutely nothing. Okay, I'm back here after spending a little time scratching my head about that extruder. It took me a little longer than I'd like to admit to remember that the one feature of the Marlin firmware is that it has a cold extrusion lockout, and what that means is that the firmware won't allow the extruder motor to move if the temperature sense is below a certain threshold, and the default on the firmware is 150 degrees Celsius. So our extruder wasn't moving just because we were below that limit. We hadn't warmed up the hot end. And then also the preheat mode that you can get to on the smart LCD or in the LCD control part of the firmware, the default that it'll warm up to here is 150, which is still below the 170 degree limit. So even using that, it wouldn't warm up enough. But once I warmed it up past that point, and that's why I changed it here. I changed my preheat so that it'll warm up to 180 whenever I choose that, which is nice to have. So then I just reprogrammed the firmware, and now if I go in here, do preheat for PLA, see there our set point says 180, and I'll just pause here for a second, let it warm up. Okay, now that it's past 170 degrees for the hot end, now we'll try again. There we go. Alright, so all three axis and the extruder are all working. So now I'm ready to actually put some filament in it and get the bed put on and get it leveled and try to print something. Okay, I've got the printer turned around and set up. I've set a roll of filament on top on the mounts, and I'm going to try to real quickly give you the crash course in getting the bed level initially and getting a test print out of the printer without boring you for too long, hopefully. So this is assuming that you've already got mechanically everything is working from your software of choice or this front panel. And what I'm going to do here is I'm going to choose the auto home. And if this part isn't already working, then you've got something else to work on first. Alright, so there it's taken the print head to this front left corner. Now I'm just going to go back and choose the disable steppers. So now I can move the extruder. And I think I'm going to get the camera a little closer here for this next bit. The extruder nozzle should be just barely above the glass, which I just put on with these 4 clips. And adjust the height of the Z endstop until it's really close, and then just use a screwdriver. It goes down here in the back. You can get to the top of the adjustment screw to get it the rest of the way so that that's real close. But to start, just focus on getting this one corner correct. Also, while I'm here, let me mention, make sure you've got each of these corner springs tightened down pretty well. You actually want to tighten them down almost until they're completely compressed, because if they're way up high, then there won't be very much tension and the bed will be a little more wobbly, and wobbly isn't good. So you can see here it's pretty stiff. So check for that. And then once this front corner is good, what you want to do now is make sure all the other corners are level. And the first thing to check is get either a ruler or calipers. And check right here from the top of the motor mount to the bottom of the X end, just as a reference point. Start on the left because that's the side that we have dialed in to be right, and you'll get some number. 69 millimeters mine is. And then on the right side, can you see? It's way off. The idler end here is higher than the one here relative to the motor. So before we go adjusting the level of the bed, you should get these right. So just turn it one way or the other so that that end is at the same height as the first one. Okay. Check it again. I should have locked this caliper so it wouldn't move. A little bit more. Okay, so now you know that the x-axis itself is level, and so now any non-leveled, any amount that it's not leveled when the x carriages move left and right is due to the bed. So immediately I can see that now I'm pushing down against the extruder is pushing down against there. So I'm just going to turn this screw clockwise a couple turns, and then I'm going to re-home the bed. And it's way too low. So it's so far low that I think what I'll do to save myself time is just lower the actual end stop a little bit. No, I'm sorry, raise it up a little bit because we're too low, so the end stop needs to move up. And you might have to, if you're moving the end stop up, you have to do it a few times because if it doesn't detect that the switch is opening, then it'll stop the process. So it's still a little too low, so I'm going to adjust it a little bit more here. That looks real close. And I'll go to disable steppers again, and now this is free to move. And the tip of the extruder is just right on the glass. Now I'm going to move it over to this side and check, and it looks pretty level. Let's say it wasn't. Then what I would do is get a pair of pliers and hold that lock nut that's at the bottom, and then just turn the screw until this is level. And then once the front two corners are good, I'll slide the bed all the way to the back, and I'll repeat the process. Here it's a little bit too high, or rather the bed's a little too far away. Go back to this corner. That looks good. so I didn't have to make too many adjustments, but you might find yourself going around and around like this a few times, so don't get too frustrated. It's important to have that part right. And now that we think it's close, what I'm going to do is, well, first I'm going to put some filament into the extruder. This goes in there, and just as a little piece of advice, when you're opening this hinged extruder, don't just pull on the top here, because it's going to put all that force on the entire x-axis. Use your other finger and kind of push up with your finger while you pull that back, because it'll really make all of this just last longer. So now I'm going to go to preheat, and we'll wait for the printer to warm up. On the SD card that's in here, I've got two models that I've already put through the slicer engine. One is a 150 millimeter square that's very thin. It's only a couple layers thick, and I'll print that first just to check our corner to corner level. And the other one is a calibration cube, which is just a box that's 25 millimeters on each side, and then I'll print that second, and then use the calipers to check to see if our printer is actually moving the distance that it's supposed to. And this preheating step isn't normally needed. You can just go straight to printing your file, and it'll do the preheat first. I'm just going to preheat once before I start here, so that I can make sure I've got to get the filament, since we just placed it into the extruder all the way down through the hot end, and I want to check that before I let the printer loose on printing. So now that it's up to temperature, I'm going to move the Z-axis up a little bit. Half an inch. And then I'll just manually turn the large gear clockwise. And we start to see filament coming out there. I'd used this hot end before, obviously, so there's some other material still in there. There's our yellow material coming through now. Okay. And then I'll take a little pair of tweezers and get that off of there. Okay. So I'm just going to give this a shot, and we're going to see what happens. So the first one is this level. This is a real simple little model that I just made in SketchUp. It's on Thingiverse, in case you want something like it. Our preheat didn't warm the bed up as much as the slicer was set to, so we have to wait for that. So it repeats the homing procedure at the start. Real thin line there, you can see it putting down. It didn't stick very well there at the back. That was actually the skirt that goes around the print. It wasn't actually part of the print, so here's the start of the print. I'm hoping you can see this. That one seemed to stick fine. When you're printing right on glass, you have to really make sure it's super clean. Dishwashing soap like The blue stuff works really well, I found. You can see some bits here that aren't nice pristine yellow. That's because that's plastic that was kind of stuck in the heat chamber of this hot end since I'd used it before. So sometimes it takes a few centimeters of plastic before it'll clear that out. Yeah, see how it's pushing up there, it's not adhering. We lost the adhesion. I'm just going to let it keep going so that I can look at the whole thing when it's done, which it should be about done. So I just moved up 0.2 millimeters to print the second layer of that model. And it's doing pretty well, but see, it's not stuck down. Our first layer didn't really stick that great. Okay, back. The bed was kind of messy. There was some fingerprints and stuff on it, so I cleaned it with soap and water and dried it off really well. And I'm just going to start that same print again. You want these clips evenly around the edge, ideally to keep the glass, or to keep the bed pressed against the glass really well. But this edge here, since the homing routine brings the extruder over and then up, you sometimes can't put them there like you saw earlier. It'll knock them off. Sometimes the first little bit of plastic will get stuck on the end of the nozzle, and then it'll cause drags like that. I can still hear that clicking in there. We're still too low. I'm gonna give this a little turn. Okay, so let me stop it for a second here so I can explain. So you notice that it's printing okay over here, and now that we're really close, when we get to this edge, we're getting that clicking because the extruder nozzle is so close that the plastic can't get out. And so as this turns, the hob to bolt turns against there, the filament isn't getting fed through. So it seems like now it's appropriate to just adjust this corner. So put the pliers on the bottom, and then I'm going to give this about one turn or so, half a turn to the right, so counterclockwise. Sorry, that was the exact wrong thing to do. The other way. So about a half a turn clockwise, which will lower this corner just a little bit. Then I'm going to clean off the bed again, get the plastic bits off of there. If you're careful and never touch this with your fingers or anything, you won't have to actually clean it very often. Just move this clip, it's going to hit it. looks promising. The skirt layer laid down pretty well. I'm sure this is hard to see on the camera because it's a light colored plastic and it's a shiny surface. But it's a pretty nice bead of plastic. Okay, I'm pretty satisfied that it's level, so just to save some time I'm going to stop that, and I'm going back here to the list of files on the SD card in this cube. I'm just going to print that now. Clean this off, get that string off there. This isn't my model, but I just downloaded it off of Thingiverse to use. And we're getting plastic here just stuck all over the end of our nozzle. I'm going to let it keep going for a little bit because sometimes it just needs to run a little plastic through before things even out. I don't know why. We're not getting great adhesion here. Stop this and turn off the stepper drivers so I can move this. So that's kind of messed up. Could be that we still don't have this quite clean enough, or it could be that our height isn't quite right. Rather than jump to any conclusions right away, I'm just going to start that over. Because sometimes you have to watch it a few times before you get the clue that you need. I don't know if I mentioned at the beginning of this is PLA filament that I'm using, or if I neglected to mention that, but it is. And that one's going on better. Okay, I'm gonna, at this point, let me zoom in Now I'm going to actually stop this print. Focus. So see how the corners are all turned up? It's a real sure sign of poor adhesion on the bed when the pointy ends of the model start to peel up like that. So I'm going to stop the printer. And I'm going to let that cool down so it doesn't deform when I take it off the bed. And then I'm just going to measure the X and Y, the dimensions on the sides, and see how they look. And while I wait for that to happen, I should also mention that you have to go through a separate procedure to adjust the E-steps. That's the number in the firmware that tells the printer how many step pulses to send to the extruder motor to get 1 millimeter of filament fed down through the hot end. And just the real quick version of that is you need to put a mark or a small piece of tape on the filament and measure the distance, say from here to that mark. Then go to your controller software, whatever that is, and move the extruder, say 10 millimeters, measure how far that mark moves, and then adjust those E-steps until it's accurate. So I didn't go through that procedure, and but that's the short version of how to do that. Okay, so let's see if our square came out square. 25.5, 25.19. So if that is repeatable, then it says that one axis is just moving a little bit too far, and we'd have to lower the step count for that. Now, completely in error, I removed that without first marking which corner or which direction was X and which was Y. So once you lose that information, you have to just repeat it. But I'll see if that difference actually is repeatable over a number of models. As for this adhesion problem that we're still having, I can take the glass off and clean it again. If I get frustrated with that and it's not working, this is my solution. It's this washable Elmer's glue stick. It's purple, and this stuff works remarkably well. If you put a real thin layer on the glass, it also does wash off really easily with water later if we want to remove it. But I'm just going to put that thin layer on there, give it a second to dry, and then I'm going to reprint our test cube. I'm going to try once again here to see if I can get this thing to focus closer. It's sticking much better, you can just tell immediately. Okay, I'm gonna let the printer run and I'll be right back when it finishes. Okay, so our print's all done, and I'm gonna pull it up here closer to the camera and hopefully you can see. So first thing you notice is from about here down, you can see how the model looks kind of slumped, kind of droopy, which is kind of an indication that the extrusion temperature is too high, or that it's not getting cooled well enough. And that happens to be the point at which I adjusted the fan duct so that it points down toward the print instead of straight towards the upper side of the hot end. The fan kind of has two purposes. To keep heat creep from moving up the barrel of the hot end and melting plastic too soon is one. But for PLA, it also kind of serves the purpose of cooling the plastic as soon as the extrusion is done. So when I moved it, it just immediately got better. And what I'm going to do now is pop the print off of here. Okay, and before I move it, I'm going to take a marker and I'm going to mark this side with an X. So now I know which side was printed by the X-axis. And yeah, that the lower half of this model looks like crap, and the top part looks really nice. That getting air blowing onto the PLA really helped. So I'm going to measure now across the top, 25.5. Measured in a few different places, and now this side, almost 26. So we're getting just a tad more distance there than the model is supposed to print. Height is right on though, 25.1. So it's pretty darn close. I'm not going to rush in and start changing the calibration numbers yet, just based on one print. So I'm probably going to repeat, print a couple other things now, make sure that the air cooling is working, doing its job, and there's always more to adjust. But we're in pretty good shape now and we're ready to print. So I think this brings to an end the videos, and I hope that this was really helpful to you. If you decide to build the Wilson printer, hopefully this will speed things along for you. And if you think I left anything out or you'd like to see something else covered, then leave me a comment or send me a note somehow and see what I can do. Good luck.